Question 2 says, if a pin is made by selecting 4 digits at random and repetition is allowed, what is the probability that the pin include exactly 2 9? If we look at the memo, there's 2 ways in which they do this. Let's talk about the first way where they provide us with literal ways of seeing this. Right. So we start off with 9 9, and we can also put it at 9 at the end. We can put the 2 9s at the end. We can put the 2 9s over here and over there. We can put the 2 9s over here and over there, and we see 1 repeating. The visuals here are just for you to understand the concept that we can move 9 around, but they're not necessarily showing you all the available ways we can do it. So one way we can actually think about it is that the 2 9s have to have a unique position. So for the first one, we can see that they're holding at 1 and 2. Then we can see that these ones are holding at 3 and 4. These ones are at 1 and 3. This is at 2 and 4. This one here, I think, oh yes, it's 2 and 4, 2 and 3. Okay. So we can also have another one with 3 and 4. I think that's what's missing here. So here we have the 3 and 4 is over there. Do you see that? 1 and 2 over there. 1 and 4. Okay, so here I had 1 and 3, but it was actually 1 and 4. So in terms of representation here, we can have this. Okay, so that's going to be 1 and 3. So in terms of the diagram, is just there to kind of for you to understand. But in terms of the number of positions we can have is 6. So the probability, right, of the 2 9s would then be equals to the way in which we can arrange the 9, which is 6 times, and there they are, and over the total, which is going to be 10 to the power of 4. This is now if we didn't have any restrictions, right? So the total possibility over the event, and that's going to give us 243 over 5,000. Now, the alternative way is what we call the combinations. So we want to know the combinations of the 4 possible ways in which we can choose 2, so 2 must be together regardless of their position. So when it comes to combinations, we don't care. What we're saying is that if I have 4 slots, how many different ways can I choose 2 of them to put in 9? Now, the equation for combination is given as C and R, where we have N, K, R, and minus, oh, sorry, I'm already writing in the numbers. Okay, so that's the equation of it, where N is the number of slots available, and 4 is those 2 arrangements which we want to move around, those 2 numbers we want to move around. So in this case, it would be 4, 2, 4 minus 2, system. And if we put that in our calculators, it would definitely give us back, it's going to give us back 6. So it means we can have 6 arrangements. So from 6 there, we would then say, okay, we have locked down the others. So we know that the 2 numbers are locked down and the rest have 9 possibilities, and we're going to multiply that with 6 because we can do this 6 times. So again, the possibility would be 1 times 1, those are locked in. Those have options over, again, the total, giving us the same 243 over 5,000.